right? Complex numbers, right? And long division and then synthetic division, and we're going to wrap it all up, right? We're going to put it all in like a nice box, and we're going to present and put a bow on it, all right? And this, we have zeros of polynomial functions. We have to think about, what?
You give it to chitlins and Africa.
Okay, if you want. And what we're going to do is we're going to sort of think about everything that we've learned and try to figure out what all, and this is all zeros upon real and non-real, complex and real numbers. So let's start real simple here. Find all roots. Okay? I say find all roots, the same thing as find all zeros. And it's the same thing as find all the solutions. And let me give you one that's already factored. Here's a function, f of x. It is x plus 2 and 3x minus 7 times x plus 4i times x minus 4i. Okay, very, very simple. I'm not going to spend a lot of time on this. There are 4 factors, there are 4 roots, and very simply, we're just going to say x equals, we're going to list them out. X plus 2 is negative 2. Be careful with this. 3x minus 7 is positive 7 thirds. So 3 goes on the bottom. And I can just write this as plus or minus 4i. Okay? Very, very simple. Nothing too much here. All right, I'll give you a couple on the homework tonight where it's already factored. There are 4 factors. You've got to tell me the 4 roots. A little bit more difficult, g of x. This is already factored. Give me x minus 9, x squared minus 4, and 2x squared plus, let's do 12. 2x squared plus 12. Okay? Still already factored, but question, think about this. What is the degree of this thing?
2.
Jordy, what did you say? What did you say? What is, Jacobs, what's the degree of this thing? 5. Why?
Because 2x squared.
I got an x squared, there's 2, and there's 2 more, and there's 1 more. So you take all the exponents and add them up because first times first times first would be 2x to the 5th, right? And 2x to the 5th has a degree of 5. I need 5 roots. Let's find them. My first one is 9. That's easy. X minus 9 gives me 9. A little bit more difficult is x squared minus 4 set it equal to 0 to find them. Remember, to find the zeros, these functions are always equal to 0.
Just plus minus 2, right?
It's plus or minus 2. You add 4 to both sides. X squared equals 4. You take the square root. I have 9, and I have plus or minus 2. Fair enough? A little bit more difficult here. 2x squared plus 12. Set this thing equal to 0. Let's solve it. Subtract 12 from both sides. They're gone. 2x squared equals negative 12. Okay, divide by 2 on both sides. X squared equals negative 6. Okay, take the square root of both sides, plus or minus, the negative comes out, and it becomes I root 6. 1, 2, 3, 4, 5 roots. X is equal to all these. Now, we could take this even further and say, what does the graph look like? Well, let's just speculate, and then we'll check on the calculator in a little while. My first root is at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know my graph is going to cross there. I have roots at plus or minus 2. So here's positive 2. Here's negative 2. Where am I going to find plus or minus I root 6? It's hidden. It's not a real root. It's not going to cross the axis. Well, let's see here. X times x squared times 2x squared. My leading term is going to be 2x to the 5th. What is the end behavior of this thing? Is it going to rise or fall to the left and the right? Let's see. It's odd, so it means it's going to look like a cubic, which rises to the right and falls to the left. So maybe, I'm just speculating, maybe this is going to come up like this. We'll check it in a little while. Maybe this is going to come down through, and it's going to come through these 2 points. But I need 2 more, so maybe it comes up and down like that and does not cross the axis. I don't know what it looks like. I'm just speculating, right? Maybe it's going to cross in 2, negative 2, and 9. But then when it makes its final turn to come back up and down, it's not going to come all the way up to the axis. We'll check it in a while and see how close we are. Now, let me give you some more complicated functions here. I want to talk about the rational root test. Listen to this very closely. I'm going to explain to you where all this thing comes from. What we're going to do is we're going to do P divided by Q. This is a rational number, or what your book might call the rational zero test. It's the same dang thing, folks. And what we're going to say is that the p-value are the factors of the constant. And that is just the number that's written out at the end, like plus 6, or minus 12, or plus 4, or minus 1, or something. The constant is the factors, the p is the factors of the constant. And q is the factors of the leading coefficient. And let me explain to you why. Again, you just believe me. You believe what I say. Okay? 99% of the time. But let me show you where this thing comes from. Alright? Let's say we have some giant polynomial. 2x to the 4th plus 9x cubed. Don't write this down, just watch. Minus 12x squared minus 10x plus 4. Okay? What is the degree? 4. How many factors are we going to have? 4. So what I'm going to do here, don't write this down, just watch. I'm showing you where this comes from. I have 4 factors that's equal to 0, right? If I knew what I was doing, I could factor it or use synthetic division or something. The rational root test says this. My first number is a 2, right? So what do all of my first values have to be? Either 2 or 1, right? So what I technically might have here, I might have 2x times x times x times x. Because what is first times first times first times first? Isn't that 2x to the 4th? Right? And what do my last times last times last times last have to give me? 4. Because that's my constant. So what are the possibilities? What are all the factors of what these numbers need to be? 2 and 1 or 4, right? So I might have 2 times 2 times 1 times 1, and that would give me 4. Or I might have 4 times 1 times 1 times 1, and that would give me 4, right? And that's the reason where each one of these little factors is going to be set equal to 0. The number that is on top, okay, listen to this. The number that is on top must be the factors of the constant. Because technically, what do I have here? I have 2x, say, plus 4, I don't know, plus or minus. If you set this equal to 0, where does this 4 go when you're finding the root? Okay, when I subtract 4 from both sides, 2x equals negative 4. When I divide by 2, right? This is the factor of the constant, and this number is the factor of the leading coefficient. Does that make sense to you? All the numbers that are on the top here are all of my factors of my constant. All the numbers that are on the bottom are all the factors of the leading coefficient. I might have a 5 right here. What would this be? It would be 5x times x times x times x, and this 5 is going to now go on the bottom. So the leading coefficient, 5, would be down here. It could be either a 5 or it could be a 1, right? So what we're going to do in these problems is make a list. Okay? We're going to make a list. Let me erase the board over here. I'm going to leave that up. And we're going to bring some polynomials over here. My question to you is this. After we make our list, how lucky do you feel in choosing the right one correctly? It's all a matter of luck. Okay? Do you think you can wisely choose the correct answer? Let's start out with my first function. X to the 4th plus 3x to the 3rd minus 12x squared plus 10x minus 10. Just for now, I don't want to solve this monster. All that I want to do is I want to make a list of all the possibilities. Granted, these are only the possible rational roots. We're not quite finding the complex ones just yet, but these are just the possible rational ones. The list is P over Q. Let's see. P are the factors of the constant. Now, when I wrote 4 times 1 times 1 times 1, what are the signs of all those numbers? Are they positive or are they negative? Positive, negative, you know what? You don't know. Do you? What? This is a positive 4, isn't it?
Yeah.
What are the possibilities? Positive, 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 positive. That would work. How about negative, 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 negative? Would that work? Yeah, because 2 negatives and these 2 negatives make positive 4. How about negative, negative, positive, positive? Would that work? Would, wouldn't it?
Yeah.
What about positive, negative, positive, negative? Would that work?
Yeah.
You see my point? You don't know what the signs are. So what I want to do is I want to write plus or minus all of the factors. Okay? So let's start with P. P is the factors of the constant. My constant is 10. So my factors of negative 10 are plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So there are 8 possibilities of the factors of my constant, right? Just think about it. Last times last times last times last must give me 10. Why is there not a 3 on this list? Because if there was a 3 as one of my constants, there's no way that you can get 10 with it. Over. What are the factors of Q? What is Q? Q is the leading coefficient. Q is U. What is the leading coefficient, Q? 1. What are the factors of 1? 1. So on the bottom is that plus or minus 1. Doesn't change anything. So what I'm looking at is all of these values right here. Okay, let's try it again. Here's g of x. We're not solving it right just yet until about 5 minutes from now. Let's just make a list. Here's one a little bit more difficult. Okay, 3x cubed minus 17x squared plus 11x minus 12. These lists can sometimes get a little lengthy. My lists are in the form P over Q. All right? On the top, I have P, which is the factors of the constant. My constant is 12. It is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Could be any of those. All divided by the factors of Q. Q is 3, so it's either 1 or 3. I'll tell you that the 1 never matters. Okay, the 1 never matters because it's just something over 1. Now, to write out the full list, notice I put a box around these ones on the top because I just had a 1 on the bottom. Okay, this is my list. There are 8 possibilities. My full list is everything on the top, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And everything divided by that 3 on the bottom. Okay? It's a possibility. In this case, plus or minus 1 over 3. Let me write it plus or minus 1/3. And plus or minus 2 over 3, or plus or minus 2/3. And plus or minus 3 over 3, which is just 1, but I already have plus or minus 1. So we don't need to write it again, do we? Next, plus or minus 4 out of 3, or 4/3. Next, plus or minus 6 over 3, which is just plus or minus 2. I already have it. Plus or minus 12 over 3, which is 4. I already got it. These are all of the possibilities of the rational roots.